Hello guys, my name is David Sandeep. In this video I would like to discuss about task 2 as data science and business analytics intern at Sparks Foundation. Task 2 is prediction using unsupervised ML. In this task we have to predict the optimum number of clusters and represent it visually from the given data set. So here we are going to import the required libraries. Here we are loading the data set, and if you look into the data set, we have columns like sepal length, sepal width, petal length, petal width, and species. This data set is all about iris uh, plant flower. Next, if you see the info, we are having 150 non-null, which are these are all 150 non-nulls. So we can say that there is no missing values. We are having 5 floating types and one object type. Here we are having values count of each categorical values. So this task we are working on clustering technique. Now what is clustering technique? Clustering technique is a technique in which a given data set is divided into groups called clusters in such a manner that the data points that are similar lie together in one cluster. Clustering plays an important role in the field of the data mining due to the large amounts of data sets. So clustering, here we are having clustering techniques like k-means clustering. K-means clustering algorithm steps are given here, like choosing the number of the clusters, select random k points, which are the centroids, assign next step, assign each data point to the closest centroid, compute and place the new centroid of this cluster. That is step 4, and last step is reassigning each data point to the new centroid, new closest centroid. If any reassignment took place, then we have to go to the step 4, otherwise our model is ready. Now how do we find the optimal number of clusters for k-means? WCSS is the within cluster sum of square distance between each point and the centroid in a cluster. When we plot the WCSS within the k value, the plot looks like an elbow. As the number of the cluster increases, the WCSS value will start to decrease. K value can be found out where the elbow occurs in the plot. So this is the code regarding we are choosing 1 to 10 clusters, and we are going to find the optimum number of clusters using elbow method. Here are the values within cluster sum of square distance. These are the values like for 10 clusters. So this is the graph which shows the elbow here, which is 3 clusters, which is the optimum number of clusters. You can clearly see why it is called elbow method from this graph. The optimum clusters is where elbow occurs. This is when the within cluster sum of squares doesn't decrease significantly with every iteration. Next we are applying k-means to the data set, like we are predicting the clusters. Next, this is the visualization for each cluster. For the cluster 0 we are having 40 points already. Cluster 1 we are having up to 50 data points. Cluster 2 we are having 60 data points, and nextly we have 2D visualization of each cluster. Like these blue points are one cluster with this one is a centroid for this green cluster. For this green cluster, this one is the centroid, and another cluster we are having this red cluster with this one as a centroid. And nextly we are having a 3D visualization of the cluster. This is the 3D visualization with three clusters, and these are the centroids. Yeah, this is all about my task as a data science and business analytics intern. Thank you for watching this video. Thank you.